Hello and welcome. So we're going to be solving my similar triangles today. Now, remember, similar triangles essentially means that you have two things by definition. You have that corresponding angles are congruent, meaning that whatever angle you have right here is going to be the exact same angle you have there, right? Likewise, your angle up at S would be the exact same angle at C, and the angle R would be equivalent to B. That's the first thing you're guaranteed with similar triangles. The second and most important property we'll be using today is that you have corresponding sides are proportional, right? So remember corresponding sides, so for example, longer side to longer side, right? Not longest, that would be this side to that side, right? But the proportion of those two yellow highlighted sides is AB to DE, or you could do DE to AB, doesn't matter which way it goes as long as you stay consistent. So if I'm going left triangle to right, I'll go AB over DE. And likewise, stay consistent, then it would be left triangle AC to the corresponding side DF, which we see right there, right? And then our last one would be left triangle to right, BC and EF, right? And what it means by corresponding sides are proportional, that proportion, that fraction that you create, the ratio, is going to be equivalent, right? So if this was, let's say, side lengths 1, 2, and 3, this would then be, if they're guaranteed to be similar triangles, perhaps something like 2, 4, and 6. So if you were to set up these actual lengths, what proportional means is that you multiplied the same number on all three sides in order to get to the other triangle. A dilation was applied to your figure, right? That mapped one onto the other. So that's how we got there. Now, if you set up those proportions, we would have had 2 over 1. We would have had 4 over 2 and 6 over 3. You'll notice all of those will give you 2, that number that we multiply to go from one to the other. That's what it means by similar triangles with are proportional. And we're going to use that to solve stuff today. All right, so for example, we're assuming we have triangles that are similar, which means we can assume we have proportional sides. All right, and with that assumption, we could say, all right, pick a triangle, go from one to the other. I like going larger to smaller, but it's not going to matter however you set this up. So I'm going to say, okay, I like larger triangles, so 8C plus 14. What side corresponds to that one in my little triangle? Now, looking at the figure, you can tell a little bit of a rotation happen. 6 is the corresponding side, just kind of eyeballing it, which one is bigger and smaller. So that means the proportion, you could say negative 8C plus 14 over 6, right? Or you could have flipped that ratio. As long as we stay consistent from bigger to smaller, it's not going to matter how we wrote it. Now, our next side we see here is a 2C. So stay consistent. Larger triangle had the top side of the fraction, the numerator. And then the corresponding side in the smaller triangle is 9. So over 9. There we go. And now you have your ratios are equal, right? Your proportions are equal. And this is an equation you can use to solve for your variable. Let's do it, right? We undo division with multiplication. So I'm going to multiply 9. And because that will only get rid of the 9, I also want to multiply by 6. What you do on one side, you do to the other, right? And then this will clear both fractions at once. We undid division of 9 and undid division of 6 with multiplication. So 9 times the left side, don't forget your parentheses, equals 6 times the other side. All right? Those parentheses aren't very helpful, so let's multiply. So we get negative 72C plus, and then 14 times 9, I believe, is 126, equals, and then 6 times 2 is 12C. Right? Now your goal is to get C equals, right? So we'll want to get all the C's on the same side. So I'm going to move it over here. I'm also going to add 72C is my next step. So on the left, my C's are gone, and we're left with just 126. On the other side, we now have 12 plus 72, which is 84. All right, so then from there, we say, okay, 84C, my mistake. All right, so now we want to divide that over. So now we have 126, and we want to get C alone, so we divide 84 both sides, and we get C equals 126 over 84. Now, remember, you need to simplify fractions if they can simplify. So I would open up whatever calculator you have and say, all right, 126 divide 84. We get 1.5, which is 3 halves. So 3 halves, right? Now, the last thing you need to double check is that this is value that actually works, right? We want to make sure that because we're working in geometry, that when you plug that value back into anything that had a C, you're going to get lengths that exist, right? Remember, lengths cannot be negative or 0. So when we plug it in, negative 8 times a fraction, 3 halves, is going to give us 12, I believe. Let's double check it just to be sure. So we have negative 8 times our 3 halves plus 14. We get 2 back, it's a positive number. Huzzah. And then clearly 2 times 3 halves is not going to be an issue, right? A positive times a positive is a positive. So from there, we know that for sure, even after checking it, our answer is going to work. And we're done. Now, example B is a little harder to see. First off, figure out where your triangles are. Here's your first triangle, right? Is that whole thing there. Your next triangle is the entire outside, right? The entire thing itself is the other triangle. So when we're creating corresponding sides on this one, we'd say, okay, corresponding side we have here, right? Our left side of this triangle, our x plus 2, is going to correspond to the entire left side of the other triangle. Now that entire left side is your x plus 2 and the 6, right? Both of those together is that whole side. So the x plus 2 plus 6, or in other words, x plus 8 is going to be the whole thing. Now this diagram is clearly not to scale. Anyone looking at that right side might be a little confused. If I know that whole thing is 8, but that portion is 5, then you know that this portion right here is going to be 8 minus 5, or in other words, 3. Like diagram, definitely not scale, but there we go. All right, and then equals, let's write that other proportion. So we did the smaller triangle first, right? Our x plus 2 first, which means we're going to start with 3 first. Keep it consistent in your proportion. And then it's going to be over the entire side, which we know is 8. And there you go. And it's going to be the exact same process as before. Fractions aren't helpful. We need to undo that division. We undo division with multiplication, right? Now on the left, keep in mind the only thing that undoes an x plus 8 is another x plus 8, right? So we have to multiply that entire denominator in order to move it. So now on the left, we have 8 times x plus 8. Oh, that was close. 8 times, whoop, that x plus 8 canceled with your denominator. 8 times x plus 2 equals 3 times x plus 8, because it did not cancel from the right side. All right, now at this, same idea as before, parentheses are only helpful if it's set to 0. So let's distribute those out. We get 8x plus 16 equals 3x plus 24. And then from there, combine your x's and combine your numbers. So I'm going to subtract 3x. I'm going to move that 16 over at the same time. So 16's cancel, 3's cancel, and you're left with 5x equals 8. And then the last but not least kind of a step, right? Undo that multiplication of 5 with division of 5, right? And you get 8/5 is a value for x. And then just double check it. If I plug that back in, we only see x in one place right there. A positive number plus something. Yeah, that's a positive number, right? It's not going to be 0, guaranteed, and it's not going to be negative, which means you are good. It's an answer that'll work. Okay? Now, the next one, very similar to the diagram we just had. It's the exact same setup. The only thing that's going to change is that we just have different lengths given to us, and we're going to have to fill it in ourselves. So AC, which is the entire length here, right? That thing is going to be x plus 28. All right. Our next one is AB, which is the entire length here. That thing is 5x plus 4. All right, now next we have AD, which is just the little length right there. That one is 12. And then E to A, which is our other little length. that is 2x. Now remember, we can set this up any way we want to, right? It's going to be big triangle to little triangle. So we'd say, all right, which way do we want it? Well, I like having my more complicated stuff in the numerator, so I'm going to go big to little. It doesn't matter. So I'm going to say, all right, big side, x plus 28 over little corresponding side. So the left side goes to the left side, so over 12. There's my first proportion, equals big side, 5x plus 4 over corresponding little side, 2x. Stay consistent as you write it. There we go. And then same process, I'm going to go a little bit faster on this one. I'm timesing 12 and 2x to undo the denominators. All right, so we're left with 2x times x plus 28 equals 12 times 5x plus 4. Distribute, we get 2x squared plus 56x equals 60x plus 48. And then from there, just a matter of solving. So I'm going to move all my x's to the same side. Because we see a square, that tells me I'm going to need to factor, use the quadratic formula, or complete the square. Whichever one you want to use, that's going to be your step here. So I'm moving everything to the same side, so 2x squared minus 4x minus 48 equals 0. Now, because we have an equation, this is going to be a valid move. I don't like having my 2 there when I factor. It's extra work, and your first step is to check for a GCF anyway, so I'm going to divide 2 to every single term, both left and right side of the equation, to keep it equivalent. And we're going to be left with x squared minus 2x minus 24. And that just gives us smaller numbers to work with and a lot easier. All right, so to factor this, I'm looking for 2 numbers that multiply to negative 24 but combine and give us negative 2. So I'm thinking negative 6, positive 4. All right, those multiply to negative 24 but add to negative 2. Excellent. Now you have a leading coefficient of 1, so x minus 6, x plus 4 equals 0, which means if we set those individual parentheses, those factors, to 0, we get x equals 6 and negative 4 as your answers. Now, same process as before, you want to plug these in to make sure that they work. Whoops. All right, so we have x equals 6, x equals negative 4. All right, so let's try 6 first. If I plug 6 in, 6 plus 28, 34, positive number, we're good to go. 30 plus 4, because 5 times 6, right? 34, ironically the same number. Coincidence, by the way. Also works, which means one last one to check. 6 times 2, 12, positive number. Yay! They all work. The next one, let's try negative 4. Negative 4 plus 28, positive, that works. Negative 4 times 5, negative 20 plus 4 is negative 16. You can't have negative 16 as a side length, which means that's not going to work. Final answer, x equals 6. Now the last but not least, this is probably as hard as it gets, is example D. Now, how many triangles do you see here? 3, right? You have the smallest triangle right here. You have a medium triangle right here, and then you have the entire triangle right there. Okay, so what's going to make this easier is to rearrange these triangles a little bit. I'm going to make it very obvious that one side is shorter than the other, right? And I'm going to put all of my right angles in the same place. Okay, not clearly, like not the same idea, but you can see that there is a hypotenuse. I can't do a straight leg to save my life. There we go, better. All right, you can see that there's the hypotenuse, there's the long leg, there's the short leg. I like making it really exaggerated so I have no question on which one is supposed to be long and which one is supposed to be short. So let's fill in some information, shall we? A to C. All right, A to C is, oops, let me use the right thing here. Okay, A to C is this side right here. And we're told that that is 26. Now that is the hypotenuse of our triangle right here. So I'm going to put 26 right there. All right, the next thing that we have is AD is 9. We see AD right here. And that's going to be of our small triangle. So I'd say, which side is that in the small? The smallest leg, the medium leg, or the hypotenuse? Well, it's going to be across or next to that right angle, and it's shorter than the other, which means it's my short leg. So that should be 9 right there. Now, DC, we can see is right here, right? It's a part of our medium triangle, and you can tell that this is the short leg, which means DC is the long leg. So DC, is 17 right there in that triangle. Now, we just have to fill in the last pieces of information. I'm going to call BC X, BD Y, and AB Z, just so we have some letters to use. So BC is right here. Okay, you'll notice that's the hypotenuse of our orange triangle, right, of our medium triangle, so it'll be that side. So I'm going to put an X down there. Y is BD, which is this side, which you'll notice is two different triangles. It's the short leg of the short leg of our orange triangle, and it's the long leg of our yellow triangle. So it's going to be Y is short leg of our orange, as well as the long leg of our yellow. Okay, make that a little easier to see. There we go. And then we're almost there, right? We have our Z, and we say, all right, that is AB. We'll see AB is right here. Also, two different lengths in triangles. You'll see it as the short leg of our blue, as well as the hypotenuse of our yellow. So we'll see hypotenuse of the yellow, short leg of the blue. Okay. Oh, there's one thing I forgot to mention. BC was also the long leg of our blue triangle. I forgot to say that. There we go. So now we filled in all the information. Now I find this a lot easier to work with than looking back at this diagram, right? So what I'm going to do now is, because these are all arrayed in the same order, you can now look at what your proportions are, your corresponding sides are a lot easier to identify. So I'd say, all right, well, I already know that these three all correspond. I know that these three all correspond. I know that these three all correspond, right? So pick a letter and start with it. I'm going to try to grab as little, as letters as I can possibly manage. The first thing that I see is X, right? You only want one letter per equation if you can manage. So when we're looking at this, I'm looking at the hypotenuse of my medium and large, as well as the long leg. You'll notice that that only uses the X's and numbers, which means I can create proportions to solve for it. Okay, so I'm going to go larger to smaller, so 26 to X, so that's hypotenuse to hypotenuse, equals X to 17, and that's long leg to long leg. All right, we kept larger triangle to smaller both ways. Same thing as what we've been doing, times 17 and X. So we have 17 times 26, I'll do that in the calculator in front of me, 442, equals X times X, which is X squared, right? And then from there, all that matters is that we just take that square root, right? Technically, you have a plus and minus, right? But you're not going to be able to use the minus because you're talking about lengths. So square root of 442 equals X. Now, if you try breaking this down, we get 2 and 221, all right? Remember how we got to this is we multiplied 26 and 17, which means that this is 13 and 17 remaining. That's not going to simplify, so square root of 442 is what we're going to keep it as, all right? And X was its own length, which means it's a positive number and it will work in our answer. Now we just need to figure out, once we know our X, how can we find our Y and our Z? Well, same idea. I'm going to try to pick stuff with just Y's. So I'll notice the long legs are just Y's and short legs are just Y's. Keep in mind, you can't use all three triangles at once. You're only using 2 at a time. So same idea. I'm going to go 17 to Y equals Y to 9. So 17 to Y equals y to 9. And then solve. Times 9 and y. And we get 9 times 17, which is 153, equals y squared. All right, square root, plus minus. Technically, you're not going to use the minus. Y is its own length. Negative answers won't be working here. So y equals the square root of 153. Now remember, this was 9 and 17. 9 is 3 and 3, which means this does simplify. You have 3 square roots of 17 as an answer. So I'll rewrite that next to my x. Done. Now we have one more left, and that is going to be z. So same ideas. I see z's here, so I'm probably going to use my smallest and largest triangle. So we see a z here, and a here, here, and here. Right? And you have just z's in the answer, so let's solve this. So I'm going to go larger to smaller, 26 to z, and z to 9. So 26 to z equals z to 9. All right, so 26, hypotenuse to hypotenuse, short leg to short leg. Okay, same idea. Now let's solve. Times z and 9, z and 9. 9's cancel, z's cancel. 9 times 26 is 234 equals z squared. Square root. Plus minus, again, not going to use the negative in this case. So we have square root 234 equals z. This is 9 and 26, which means that this is 3 and 3, 2 and 13, right? No more pairs other than that 3, so 3 will come out. And then 2 times 13, or in other words, 26, is what stays behind. And there you go. Answer, you're done. That triple triangle problem is the most work, honestly. Take your time with it, and I would highly recommend to rewrite those triangles to make it a lot easier to see those proportions. All right, there you go. Thanks for watching.